My name's Phil. I'm an Android developer at Shopify in Toronto, and I'm here today to talk about architecture components. So, as the title of the presentation cleverly suggests, I wrote an app that uses architecture components because I wanted to sort of see how they performed in a sort of a real-world situation. So, today this morning I'm here to sort of give you an overview of my experience, how they worked for me, what problems they solved, and what problems they created, sort of, if any. I've tweeted out a link to the slides if you guys want to follow along, or if you want a closer look at. There is some code on here, so if you need a closer look, feel free. So first off, what are architecture components? If you're in this room, you probably already know the answer to that, and you may already be using them in your projects already. But the official definition from Google is this. So it's just a collection of libraries that help you design robust, testable, and maintainable apps. And so I guess the goal of this presentation was, and the experience in general, was I set out to see if this statement is true. And so if my app really would be robust and easily testable, more so than the typical patterns I would use to make an app. So before we sort of get started with architecture components, just a word on architecture. For that word is, for a long time there wasn't one in Android. I'm sure we all know that. But recently Google sort of announced or released their architecture guidelines, which and their sort of, I guess, official recommendation follows an MVVM architecture pattern. And so for anyone who's not quite familiar, just MVVM stands for model, view, model, and specifically it just separates responsibilities into a few different layers. First you have the view, which is represented by the activity in the fragment, and that's the V, and that's sort of responsible for showing data on the screen and reacting to user input. Then you have the view model, which is the VM, which is responsible for storing and managing data required for the view, and as well getting the data from a repository, which connects to the model, which is the M. And those are a set of classes that sort of represent the data that you're working with. So now let's review how the architecture components help us achieve this. So there's a number of different sort of architecture components you can use. The first one I chose was LiveData. And essentially LiveData is just a wrapper around your models class or your model classes to make them observable, so that View, for example, can subscribe and get notified on any updates in the data. Then we have ViewModels, which are different than the generic term ViewModel. ViewModels are an actual a base abstract class in Android that you can inherit from, and it's responsible for, as I mentioned, sort of storing data. And the reason, or managing data, the reason you would want to use this specifically is that the view model that comes with Android survives configuration changes, which means that when you rotate your device and your activity gets recreated, it's going to get the same view model that it had when it was originally created, which is great, so you no longer have to requery the data. We then have Room. And Room is basically just an abstraction over SQLite that lets you communicate with your app's database, and which is great because we no longer have to use the just abysmal Android SQLite APIs, which is no fun for anyone. And in the actual, in the sort of architecture pattern, it's recommended that you don't interact directly with Room, but you sort of hide it behind a repository, which sort of gives you a sort of one point of access for all your app's data. And there's also a paging library that's including with architecture components, but I didn't end up using it, so I'm not going to say too much more about that. But so now that we sort of kind of got all the housekeeping out of the way, we can actually sort of start talking about how this all works together. But before we do that, I'd like to actually give you a bit of advice, which I think is probably the best advice you will ever get in both your professional or personal life. And that is that right there. Now, what I actually mean is don't only listen to me. And I say that just because I'm certainly not an expert at architecture components, but this talk is more about sort of my experience using them and learning them, and sort of how I found using them in a practical situation. That being said, if any of the code up here sort of looks a little fishy to you, or you've maybe approached a similar problem in a different way, please let me know, and because I'm still learning this as well and I'm trying to get better, so if you see any improvements or anything that looks kind of fishy, please let me know. So the whole experiment I did starts with a sort of a simple reminders app, which is the app that I created. So to give you an idea of what sort of that looks like, here we have sort of just a list of reminders that I've set on my phone, and now I'm creating a new one, reminding me to floss. It's important. And I'm going to set it for 9:30 p.m. And I'm going to have it recur every day. So now how that works is basically every day at 9:30, I'm going to get a notification on my phone reminding me to floss. So the main functionality of the app was handled with a sort of a list detail configuration, or list detail activity configuration. And each activity has a view model, and that view model exposes the live data to the activity. So the activity can observe that live data and do the appropriate actions when that data is changed, such as displaying the list of reminders on the screen. And in order to react to user input, for example, like if I press the delete button because I don't want to floss anymore, the activity will call a method on the view model saying that, hey, Phil wants to delete this reminder, and then the view model is responsible for taking care of that, whatever it needs to do. And in order to get all the data, the view model gets all the data through Room, which is, as I mentioned, this abstraction over SQLite. And in my case, it's getting it through this reminder repository. So as far as the view model is concerned, it doesn't care where the data is coming from. It could be coming from the database, which it is in this case, or a web service or a carrier pigeon or whatever. It doesn't care. So and so that's sort of the basic setup of how I set up my app and how I made it sort of work with the architecture components. And so now we're just going to go through sort of each component, see how it all works together, and sort of how I implemented it. So first up is LiveData. So LiveData, pretty simple. As I mentioned, you're able to subscribe to it and receive data updates. Nice thing about it is lifecycle aware, which means that if your activity subscribes to it and then your activity is killed, either in the process of, say, a web service call running, and then when it completes and it tries to push the data, or the data is updated in the LiveData object, if your activity is no longer there, it's not going to get delivered, and you don't have to do any sort of unsubscribe or anything like that. It's just handled by Android for you. And while LiveData is the main class that this all stems from, there are a couple of useful subclasses that help you in certain situations, being Mutable LiveData and Single Live Event, and we'll talk about both of those. So here's the, can you guys see that? Is that, no? Okay. I don't really know what to do. Anyway, sorry everyone. So I wonder if I can make this. Does anyone know? Can I sort of increase the resolution on Keynote or anything like that? No? Okay. Sorry? Yeah, I can certainly try that. Yeah, probably not. Okay, I'm sorry. So anyway, I'll describe it. Up at the top we have, so this is the activity, or the view model for the main activity, and it's got a list of reminders that it is grabbing from the database, and that list of reminders is wrapped in a LiveData object. And so then the activity can grab that LiveData object and subscribe to it. And anytime the LiveData is, or the data that list of reminders is updated, that code in that observer will get executed. So pretty simple, just a publisher subscription sort of setup. But one really neat feature about LiveData is that if LiveData is backed by, say, a database query from Room, that when the backing data or data in the database is updated, that data automatically gets pushed to this LiveData object. So in my case, when we sort of saw that list detail setup, when I added a new reminder to the list, or from the detail activity added a new reminder and clicked save, my list on the main activity was automatically updated without me having to do anything, because Room said, oh, hey, here's some new data, and it basically went from database to UI without any extra code. And if you're anything like me, my reaction was kind of something like that. I was really excited. I mean, and I know this is something that you can do with other libraries as well, but it's pretty exciting to see this come in Android and that we don't have to do anything else. So I mentioned there were a couple of other subclasses, one being Mutable LiveData. So on this slide that nobody can read, we have a couple of Mutable LiveData objects. In this case, they're representing sort of the visibility of, they're of type Boolean, and they're representing the visibility of a few views on my main activity. One thing to, and so these, I've defined these as Mutable LiveData. And so what Mutable LiveData does is it's a subclass of LiveData that exposes the setValue method, which means that you can set the value yourself, making it mutable. So here, as I mentioned, I have two representing the visibility of a couple of views. You may notice that they're, well, or not, you may notice that they're typically defined as private. So they're not, those Mutable LiveData objects are not directly exposed, and that is because otherwise the activity would have the ability to, say, modify the data. So typically you would declare them as private and sort of just provide a getter method that just returns the LiveData sort of component, I guess, of the Mutable LiveData, so that any activity doesn't have the ability to change the value. And to set the value, it's pretty simple. You just set a value in the value parameter, and then anything that's subscribed to that will automatically get that update. So any subscribers in the view will get, oh, hey, the value is now changed to true or false. Similarly, there's also what's called a single live event. And what single live event does, I guess the best way to think of a single live event is kind of like an event on an event bus. So it's basically you just send out an event and say, okay, this happened, and any subscribers will get updated. The big difference between single live event and a LiveData or a base LiveData object is that once you will only receive events once you're actually subscribed to the single live event. So with LiveData, once you subscribe, you get whatever is the most recently stored value in that object, in that LiveData object. With single live events, you don't. So you only get the values once you're subscribed. So this makes it really good for things like single UI updates, like showing, I think the example Google gives is showing a snack bar. And so that's good for that reason, because otherwise, if you sort of rotated your device, if you rotated your device and resubscribed to the view model, then you would get that value again, and you would show the toast again or the snack bar again, which would be weird. So and then to actually sort of use it and set a value, it's pretty simple. You just post the value, and in this case, I'm sending the notification ID, and the subscriber in the main activity would get it. One little disclaimer about single live event is that it's not actually included in the architecture components libraries. So I pulled this from a Google sample repository on GitHub, which is actually really fantastic, and if you're interested in this, I definitely recommend checking it out. But it's basically a repo that shows you how to use architecture components in a lot of different scenarios. And in that example, you make heavy use of single live event, and single live event also seems to be very widely adopted in the community as well. So I imagine at some point it might get into the libraries. I'm not quite sure why it wasn't to begin with, but just something that you have to just keep in mind to import yourself. And so, as I mentioned, one of the goals of all this was to improve sort of the testability of the app. So let's sort of see how that works, how you would test LiveData. And I mean, the short answer is you don't really test LiveData, but you would attest the classes that hold it. So, for example, this is just one of my simple database tests. Basically just inserting some reminders into the database and then grabbing it and making sure you get the correct one. The reason I'm bringing this up is just a little bit of a caveat. So you can see there that there's, I'm calling a getValue method on a LiveData testUtils class. And what this does is this actually retrieves the value from the LiveData object right away without having to subscribe to it, and which is really handy for tests like this. Once again, this is not included in the libraries. Not quite sure why, but once again, it's in the samples, and once again, people are using it quite a bit. So again, just something you have to import yourself. So to sort of wrap up with LiveData, the pros is they're pretty simple to implement. Just subscribe to it. Your subscribers are automatically updated with any backing data change from Room. And they're lifecycle aware, which is really handy. So some things to look out for. They're not necessarily cons, but just things to be aware of. We've got, if you're using a mutable LiveData, I found it was a good idea to create a getter so that you're not exposing to keep it immutable. For sort of one-time updates, you can use a single live event, which again you'll need to import. And I mean, it's limited to RX. It's limited compared to RX Java. It's a similar sort of pattern where you're, say, subscribing to something, but you don't get all the nice and vast array of operators that, you know, I like to pretend I know what's going on with them and that I understand them. But so yeah. But if you're a real RX Java junkie, then that's just something to be aware of. So the question is, like, if you ask me personally, should I use LiveData? I would say yes. So does Brent. So, and for a lot of really good reasons. One is that it allows you to really easily observe changes or data changes from your models. Works really nicely with the Android lifecycle. And as I mentioned, you can accomplish these things in other ways, but it's easy and it's really nice and designed to work with Android out of the box. So really handy. So moving on to ViewModels. So as I mentioned, ViewModel contains the live data and any business logic required to display the data on your view. It reacts to user input by getting notified from the activity. And as I mentioned, it survives configuration changes, which is great. So any data stored in the ViewModel, you will just get back again when your activity is recreated, and you don't need to recreate the database or anything like that. So, again, sorry about this. There's a lot of code on here, but we'll go through it sort of bit by bit here. So this is my main activity or the ViewModel for my main activity, which just extends from ViewModel up there. And it's just got a series of all the code you require. So it's got my live data objects. It's got all my single live events. It's got my getters for any mutable live data. And then it's just got all the methods that the activity would call in order to say, hey, an action has happened. Like the user wants to delete a reminder, the user is adding a new reminder, all that kind of stuff. And so it would just call these expose methods on the ViewModel, and the ViewModel would act accordingly. Now I mentioned that the ViewModels survive config changes, and that is because you don't actually instantiate them directly. So instead of, I know we're all in Java we're all very used to saying this equals new something and creating an instance that way, or Kotlin, same thing, just minus the new. But in this case, you actually get Android to create it for you. And what Android does is you say, hey, I need a ViewModel for my main activity, and it's of main activity ViewModel. It's the main activity ViewModel class. And so what this does is it creates it for you and then caches it so that when your device rotates, it just goes and pulls that existing one and throws it to your activity because it knows it's the same activity, it's just being recreated. So that all works without you having to do anything out of the box, which is great. Sorry, it works out of the box with you having to do anything. So When I sort of looked at this, I was like, okay, that's great, but what if I need to throw some constructor parameters into this view model, which is kind of a big deal. So how that works is you have to create an implementation of this view model factory interface. And this comes with Android. And in this case, you can throw whatever parameters you want in the constructor of this factory, or you can inject them, or however you want to do it. And when Android actually creates the view model, it then uses the view model's constructor that you define with those parameters and just tosses them in there. So kind of solves that problem for you. It's actually kind of surprising that, at least when I checked it out, on the documentation, this really isn't very well explained, or there are no examples, and I don't really know why. But if you Google it, this is like the first thing that comes up. So this is how you do it. It's just not very well explained. And then in the instance where you don't actually need any constructor parameters, then you can just get rid of that factory, and you just say viewModelProviders.of and provided this, which is the activity or the fragment that is calling this. So how is it to test view models? Turns out it's really easy because it's all just JVM tests. This has no correlation to Android or the lifecycle or anything like that. You just write strict JVM tests. And so I mean there's a lot of code on here, but there's nothing all that exciting, but I'm just sort of showing to show you that they just do look like JVM tests. You set up your data, you do your thing, you have your mocks, you do your assertions, all that kind of stuff. So really easy, just JVM tests, and they run really fast. So great. And obviously that's one of the goals of having a defined architecture, is to make it more testable. So works really well in that regard. So some of the pros for view models, we have an Android supported architecture now, which is amazing and fantastic. And they persist config changes, which is also amazing and fantastic. And again, really easy JVM tests. So a lot of really good benefits you get from using a view model. Some things to be aware of: don't instantiate them directly. You can if you want, but then you don't get the nice config change behavior. If you need constructor parameters, then implement that factory, and it'll take care of it for you. And if you need a context in your view model, there's actually another class that you can extend from instead of view model, which is Android view model. And what Android view model does is give you a reference to the application's context. So you can debate whether or not it's a good idea to have context in your view model, but if, say you need some resources that you need to determine, which string to send to your view, this is a really good way to do it, because it just gives you your application context, which is safe to use with a view model in terms, throughout all the config changes and all that kind of stuff. So, should you use view models? Yeah, once again, I'd say yeah. It's similar to a lot of other architectures, but view models specifically, they solve a lot of the Android lifecycle annoyances for you. So really, really handy. That being said, you don't need to migrate over. If you're happy with your existing architecture, then that's cool. That's cool. But if not, then this is definitely something I'd say to take a look at. So moving on to the last component that I used, we have Room. And as I mentioned, Room is an abstraction over SQLite, and it allows you to communicate with your app's database in a really easy way. As I mentioned, if the query returns a LiveData or a flowable or observable from RxJava, it will automatically push updates to the subscribers. And just another sort of good idea is to not sort of interact with Room directly, but access it through a repository. So just to sort of keep everything kind of separate. So to get started with Room, the first thing you need to do is tell Room what kind of data that you want to store. So in my case, I was storing a reminder. And so I made a simple sort of reminder class to handle that. And it's basically just a model with a bunch of properties and nothing too crazy. There's just a few annotations you have to toss on. So up at the top, you may notice that the class itself is annotated with the entity annotation. and with a table name. And what that does is that tells room where to store it. And I've also tossed a primary key annotation on my ID field, and so that room knows that that's the primary key. So nothing too crazy here, but if you have a keen eye, you may notice that all these properties are vars instead of vals. And that is because room requires public getters and setters on all your classes or on your entities, which is a drag if you dig immutability. There are some, I looked into this quite a bit, and there are some examples on the internet that claim you don't need to, you can do it with immutable properties. I'm skeptical, because I know I should probably just blindly trust the internet, but I'm skeptical because I wasn't able to get it working. But if you have, and if you've been able to do this, please let me know, because I would love to know what I'm doing wrong and why I can't get it to work. So now that we've created our reminder, we just need to create the methods that will access the database, and that's just done through an interface, so very similar to retrofit if you've ever used that. And you annotate this interface with a DAO annotation for data. Thank you, data access object. Thank you. And so for sort of simple database operations like insert, update, delete, you create the method and then just annotate it with either an insert, update, or delete annotation. And Room is smart enough to know that, if you call that update reminder and pass it a reminder, it knows that, okay, you're just trying to update this in the database. For anything more advanced, then you need to write your own query, and you just toss that into a query annotation. So really pretty simple, really easy to sort of set up. And one more method one more obvious is that the repository, when you're getting a reminder by ID, for example, the repository directly just calls that method, and it says, okay, get reminder by ID, and Room will return that for you, wrapped in a LiveData object. So what about testing? So again, tests are pretty simple. They are instrumented tests, so you do need a device or an emulator, but we all have probably dozens of them, so not a big deal. And as you can see here, the tests are pretty simple, and they just kind of look like JVM tests, or typical unit tests. Sorry. So you've got your again, this was sort of the test we saw a little earlier of pulling a reminder by an ID. So you insert a bunch of reminders into your database, and then you query it based on an ID and make sure you get the correct one. But a couple of things I sort of want to point out here. One is that you may notice up here I've got a sort of a setup phase where you're actually building an in-memory database. And so what this does is it just creates a database for the purpose of your test. So it's not querying your app database or anything like that. And so now you can do whatever you want to your data and then run your test. There is also, right below it, you will notice there is an allow main thread queries method call. And that is because, by default, Room will not let you do database operations on the main thread, which is a good thing. But if you're anything like me, when I was setting this up, I wrote out my interface, I got everything hooked up, I was really excited to go. I open up my app, and it just crashes right away. And I'm like, okay, I probably did something stupid. So I go and look at the logcat, and it gives you this very clear warning about no database operations on the main thread. And I looked something like that. Because I was annoyed. So, obviously it's a good thing to do, but it was just annoying sort of getting things, when I was sort of getting things set up. So just something to be aware of, that you will have to implement the threading on your own. One little caveat to that is that if your room query returns a LiveData object or a flowable or observable, then Room will actually do the threading for you in that case. So you don't need to worry about handling threads for say, querying a reminder. It will do that because it's smart enough to think, well, okay, this guy's probably trying to observe it on a main thread, so we're just going to handle the threading for you. So, pros for Room. No more SQLite APIs, which I feel I don't need to expand on that point any further. Really easy testing, and really nice auto-updating feature with LiveData and RxJava. So, some things to be aware of. You require a device or emulator for testing. The entities do need a public getter or setter, as far as I know. And you do have to handle the threading yourself, unless, as I say, you're subscribing to a LiveData object. So, should you use Room? I'm a little more lukewarm on this one. Bit of a cop out, but it's. I mean, if you don't have a database, or if you don't if you're not using an ORM or you're still using some other persistent strategy you're not happy with, then yeah, go for it. It's, as you can see, it's fairly easy to set up. The LiveData auto updating is really convenient. But I mean, if you're in a situation, if you're using something like Realm or ORMLite, or you really like your persistent strategy and you're not really bothered in changing, then it's cool, because it's you know, the nice thing about architecture components is that you can use them all individually or all together. So if you just wanted to use a ViewModel and LiveData and no Room, that's fine. So yeah, so I mean, I guess in this case, I think it just sort of depends on where you're at and in that sort of in your project. So I've mentioned a few times that Room also worked with RxJava. So I just want to sort of show you how that looks like. So if we go back to our sort of our reminder data access object, we had this method here that returns the list of all your reminders, and you can see that the return type is a LiveData that wraps a list of reminders. To make that work with RxJava, all you need to do is change the return type to a flowable with your list of reminders, and that's it. So really quite easy. And then when you actually go to subscribe to it, we had up here what we had originally, which is where, you know, adding an observer to the LiveData object. This just becomes a very typical subscribe pattern that if anyone who's used RxJava is probably very familiar with. And the nice thing about RxJava using this RxJava with Room specifically is that it can actually make the threading quite a bit easier. At least I found. So, you know, for example, this might be sort of like a naive implementation of how you might handle threading for any sort of, you know, insert, update, or delete, or any operation like that. With RxJava, what you can actually do is wrap that in a disposable, so that any subscribers can provide a callback if they want, and, you know, to get notified when it succeeds or if it fails. And if not, you don't need a callback, that's fine. But it also, as far as the caller of this method goes, it has no idea that it's, you know, doing any threading. So this worked out really well for me, this whole sort of setup. And if you've been paying attention, you know that this is coming. So this was my existing test for getting the reminder list through a LiveData object. And we see that it's got that LiveData test utils call up at the top. With RxJava, it's a little different. So similar sort of thing. You set up your test, but then you can call this sort of handy test method on your flowable, and then do your assertions after that. So in my case, to me, I found this to be, I guess, more of a natural and more fluent API for testing. So for all my tests, it made them a lot easier to write, a lot more fun to write, and that kind of stuff. So in my situation, this was really handy and worked out really well for me. And so when combining sort of the question then is, okay, which one do you want to use, like LiveData or RxJava? I personally found that they worked really well together for certain scenarios. So in my experience, I used RxJava for a lot of the database operations. So it returns, it would return, you know, say a flowable, and use it for the threading for any sort of for any insert or updates or anything like that. And I used LiveData for any data that I controlled myself. So or something that was not necessarily controlled myself, but controlled, say, local to either the ViewModel or anything like that. And because LiveData is simple and it does the job that I needed it to do. So I mean, this may not work for you, or you may think this is just a terrible idea, but when I was writing this app, it worked really well for me, this sort of combination. So I know that was a lot of info, so to just sort of recap, some pros for using architecture components. We now, as developers, have a lifecycle aware, kind of officially supported architecture, which is really handy. The LiveData auto-updating is a really nice feature. And a really great thing about them is that you can, as I said, you can sort of use them piecemeal. You can, if you want to just use room, that's fine. If you want to use LiveData with a presenter class, that's fine. You can do whatever you like, but it's great, and because you can sort of mix and match whatever works for you. And that being said, that also means that your app's not going to break if you don't want to use any architecture components whatsoever. So these are sort of, you know, your existing apps. If you have everything in an activity, I feel bad for you, but I mean, it will work. So you don't need to actually rush to implement anything. Some things to be aware of. We've got single live event and LiveData test utils are useful classes, but they're not included in the library. You do the documentation for the factory when providing constructor parameters for a view model is also not great, so just something to be aware of. And you do have to implement the threading for room yourself. And I know I keep going on about this, and I know threading is something we can all do, but you know, we're busy. We don't have time for that. So going back to sort of the slide we looked at right at the beginning to sort of see how this. Let's see if we can answer this question now. So, the question we were trying to answer was, did architecture components allow me to write a maintainable and testable app? And of course, that goes into should I use them? And probably not a surprise, but yeah. So, in my case, I'm very happy with the way that my app turned out. I know obviously it was just sort of a greenfield project and everything, but I'm very happy with the way it's set up. And when I want to go and add new features, I'm very confident it's going to be pretty easy to do so because things are sort of set up in a nice way. And everything works with Android, which is great. And I guess the big takeaway I want to say is I know there were definitely some gotchas and annoyances, but I didn't come across anything that would make me not recommend it to someone else to give it a shot. So for what that's worth, if you trust me, then I'd say go for it and give it a shot. Coming into this, I'd had a lot of experience with an MVP architecture, and I mean, while this is similar, I found it a bit easier to use, more natural to test, and everything just works really well with Android, which is great. And I think it's a really good step forward, like especially for our Android developers. So if you want to help, I've got my product's open source. The link's up there on GitHub. It's if you see something if you actually want to see the code, you can go check it out. If you see something I did wrong, like feel free to make a PR. If you hate what I did and want to rewrite the whole app, make a PR. I'll try not to get horribly offended. And if you need more info, there's a lot of great resources here. We've got the official documentation from Google. We've got the samples from, as I mentioned, on the GitHub repo. This is a really great starting point to see how things work. And there's a lot of different scenarios. They've got sort of a basic one. They've got one in Kotlin. They've got one using Kotlin and RxJava. Like each one sort of there's a different branch for each sort of topic or each scenario, which works really well. And there's a recent episode of Fragmented, the podcast that talks about architecture components, and it goes into a lot of detail, and it's also a great source if you're looking to know more about this. So thank you very much for listening. I'll be around for the rest of the conference. So if you want to talk about architecture components or Android or baseball or Canada, come find me and we'll talk. And thank you very much.